Welcome to sureshbhattclasses. In this video, we are going to learn quantitative aptitude topic H.C.F and l.c.m. All the topics of quantitative aptitude are useful for many competitive exams like SSC CGL, Bank PO, RRB, Railways and many more. These topics are also useful for many entrance exams like GRE, GMAT, CAT, SAT, ACT and many more. Please watch all my videos on quantitative aptitude topics useful for all these exams as well as all job interviews. Let's go to the topic HCF and LCM. We first understand the important definitions. Point 1. Factors and multiples. If a number A divides another number B, then number A is called a factor of B and B is called multiple of A. Point 2. Highest common factor HCF. The HCF of two or more than two numbers is the greatest number that divides each of the numbers exactly. HCF is also known as greatest common divisor GCD or greatest common measure GCM. How to find HCF of given numbers? Part A. Factorization method. Write each numbers as product of prime factors, then product of least power of common factors is the required HCF of given numbers. We will learn it by one example. Example 1. Find the HCF of 924, 1092 and 1428. We write 924 in its prime factors. The prime factors of 924 are 2 to the power 2 multiplied by 3 multiplied by 7 multiplied by 11. These are the prime factors of 924. Now we find the prime factors of 1092, and the prime factors of 1092 are 2 to the power 2 multiplied by 3 multiplied by 7 multiplied by 13. Then prime factors of 1428, 2 to the power 2 multiplied by 3 multiplied by 7 multiplied by 17. These are the prime factors of 1428. Now we have to find the common factors of these numbers, and we find that 2 to the power 2 is common in all the three numbers. Then 3 is common in all the three numbers and 7 is common in all the three numbers. So we write HCF equal to 2 to the power 2 multiplied by 3 multiplied by 7. These are the three common factors in all these three numbers, and the value of 2 to the power 2 is 4 multiplied by 3 is 12 and 12 times 7 is 84. Therefore the HCF of 924, 1092 and 1428 is 84. I hope you have understood how to find the HCF by factorization method. Point B. Division method. If we have to find HCF of two numbers, then divide larger number by smaller number and find the remainder. Now divide the divisor by the remainder. This process we continue till the final remainder is 0. Then the last divisor is the required HCF of given numbers. We will learn it by one example. Our next example, example 2 is find the HCF of 3538 and 3712. Before solving this example, I request you to please subscribe to this channel. Here the smaller number is 3538. So we will divide the larger number 3712 by 3538. 3538 divides 3712 for one time, and remainder is 12 minus 8 is 4. We carry 1, so it becomes 10. 10 minus 3 is 7, and 6 minus 5 is 1, and 3 minus 3 is 0. So remainder is 174. Now we will divide the divisor by this remainder. So we divide 3538 by 174. 174 divides 353 for 2 times. 2 times 4 is 8. 7 times 2 is 14. We carry 1 is 2 plus 1 is 3. On subtracting, the remainder is 5. We carry 8. Now 174 cannot divide 58. So the remainder is 58. Now we divide 174 by this remainder 58. And 58 divides 174 for 3 times. 8 times 3 is 24. We carry 2. 5 times 3 is 15 plus 2 is 17. So 58 completely divides 174 for 3 times, and the final remainder is 0. The last remainder 58 completely divides 174, and the remainder is 0. So the last divisor 58 is the required HCF. So the HCF of 3538 and 3712 is 58. I hope you have understood the division method of finding the HCF of two numbers. Point C. Finding HCF of 3 or more numbers by division method. Suppose we have to find HCF of 3 numbers. First, find HCF of any 2 numbers. Then find the HCF of third number and the number obtained as HCF of first 2 numbers. Similarly, the HCF of more than 3 numbers can be obtained. We will learn it by one example. Our example is example 3. Find the HCF of 1296, 1872 and 1332. We can find the HCF of any 2 numbers out of these 3 given numbers. So first we will find the HCF of 1296 and 1872. 1296 divides 1872 for one time. On subtracting 1296 from 1872, the remainder is 576. We divide 1296 by this remainder 576. 576 divides 1296 for 2 times. 2 times 576 is 1152. On subtracting 1152 from 1296, we get remainder 144. Now we divide 576 by 144, and 144 divides 576 for 4 times, and 4 times 144 is 576, and our remainder becomes 0. So the last divisor 144 is the HCF of 1296 and 1872. Now we will find the HCF of this 144 and 1332. So we divide 1332 by 144. 144 divides 1332 for 9 times, and 9 times 144 is 1296. On subtracting we get 36 as remainder. Now we divide 144 by 36. 36 divides 144 for 4 times, and 4 times 36 is 144, and remainder is 0. So the last divisor is 36. So our HCF is 36 for 1296, 1872 and 1332. I hope you have understood the method of finding HCF of 3 numbers by division method. If there are more than 3 numbers, then we continue this process with the 4th number, 5th number and so on. So we can find the HCF of 3 or more than 3 numbers by this method. Point 3. Least common multiple, LCM. The least number exactly divisible by all the given numbers is the LCM of given numbers. How to find the LCM of given numbers? Part A, prime factorization method. Write each number into product of prime factors. The LCM is the product of highest power of all the prime factors. We will learn it by one example. Example number 4. Find the LCM of 18, 24 and 30. Now we will first factorize the given numbers into prime factors. 2 times 9, and 9 is 3 to the power 2. So the prime factors of 18 are 2 multiplied by 3 to the power 2. Now the prime factors of 24. It is 8 times 3 and 8 is 2 to the power 3. So the prime factors of 24 are 2 to the power 3 multiplied by 3. Now the prime factors of 30. The prime factors of 30 are 2 multiplied by 3 multiplied by 5. On observing the prime factors, the involved prime numbers are 2, 3 and 5. So we have to take the highest power of 2, 3 and 5, and that will be our LCM. Highest power of 2 is 3, that is 2 to the power 3. Then highest power of 3 in all the constant numbers is 3 to the power 2, and the highest power of 5 is 1. So we have taken the highest power of prime factors in the given numbers, and this is equal to 2 to the power 3 is 8, 3 to the power 2 is 9 and 5 as it is. So our LCM is 360. I hope you have understood the prime factorization method of finding LCM of given numbers. Now we go to the another method of finding LCM of given numbers. Part B, shortcut common division method. Arrange all the given numbers in ascending order. Divide by a prime number which divides exactly at least 2 numbers and carry forward all other numbers. Repeat this process till no 2 numbers are divisible by common number. The product of all the divisors and undivided numbers is the LCM of given numbers. You will understand this shortcut method by one example. So we go to the example. The given example is example 5. Find the LCM of 12, 18, 30 and 20. We arrange all these numbers into ascending order. 12, 18, 20, 30. Now we start dividing these by prime numbers. So the least prime number is 2. 2 divides 12 for 6 times, 18 for 9 times, 20 for 10 times and 30 for 15 times. Still there are two numbers which are divisible by 2. So we again divide it by 2. 2 divides 6 for 3 times. We carry 9 as it is. 2 divides 10 for 5 times. And we carry 15 as it is, as 15 is not divisible by 2. Now there is no common two numbers divisible by 2. Now the next number is 3 and we find that there are 3 numbers which are divisible by 3. So we divide these numbers by 3. 3 divides 3 for 1 time, 9 for 3 times and 5 is not divisible by 3, so we carry 5 as it is. 3 divides 15 for 5 times. Now there are two numbers which are divisible by 5. So we carry 1 as it is, 3 as it is, 5 divides 5 for 1 time and again 5 divides 5 for 1 time. Now we have divided all the given numbers by prime numbers. So our LCM will be product of all the divisors. Divisors are 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 3 and all 1 1 1. Now the product of these numbers is 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60 and 60 times 3 is 180. Therefore our LCM is 180. I explain this method again. We arrange the given numbers 12, 18, 30 and 20 into ascending order. So we write 12, 18, 20 and 30. Now here 12, 18, 20 and 30 all are divisible by 2. So we divide these numbers by 2. On dividing we get 2 divides 12 for 6 times, 18 for 9 times, 20 for 10 times and 30 for 15 times. Again there are two numbers which are divisible by 2. Those numbers are 6 and 10. So we divide by 2. 2 divides 6 for 3 times. We carry 9 as it is, as 9 is not divisible by 2. Then 2 divides 10 for 5 times and 15 is not divisible by 2. So we carry 15 as it is. Now there is no number which is divisible by 2. The next prime number is 3 and we find that 3 divides 3, 9 and 15. So we divide these numbers by 3. 3 divides 3 for 1 time, 9 for 3 times. We carry 5 as it is, as 5 is not divisible by 3 and 3 divides 15 for 5 times. Now we find that there is no two numbers divisible by 3, but we see that there are two numbers divisible by 5, so we divide it by 5. We carry 1 as it is, 3 as it is and 5 divides 5 for 1 time and again 5 divides 5 for 1 time. So now we start multiplying all the divisors. 2 multiplied by 2 multiplied by 3 multiplied by 5 and there are all the remaining numbers are 1, 3, 1, 1. As 1 do not affect the multiplication, so the number left is 3. So we multiply it by 3. So we get 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 3. And the product of these numbers is 180. So our LCM is 180. I hope you have understood the shortcut method of finding the LCM of given numbers. Before going to the next point, I request you to please subscribe to this channel. Point 4. Important formula. Product of two numbers equal to product of their HCF and LCM. And we will learn it by one example. Example 6 part 1. If HCF and LCM of two numbers are 54 and 4158 respectively, and one of the two numbers is 594, find the other number. The product of two numbers is A multiplied by B. A and B are two numbers, is equal to H, I write for HCF, multiplied by L, I write for LCM. So A multiplied by B equal to HCF multiplied by LCM. Now we put the values. The one number given to us is 594 and we have to find the other number B. So we write B as it is, equal to the product of HCF and LCM. HCF is 54 multiplied by LCM is 4158. So B equal to 54 multiplied by 4158 divided by 594. As HCF is 54, so it must divide 594. So 54 divides 594. 54 times 1 is 54. 59 minus 54 is 5. We carry 4. So it is 54 again. So 54 divides 594 for 11 times. Now we divide 5158 by 11. 11 times 3 is 33. 41 minus 33. The balance is 8. We carry 5. 11 divides 85 for 7 times. 11 times 7 is 77. And 85 minus 77 is 8. We carry 8 again. So it becomes 88. 11 divides 88 for 8 times. So the another number we get is 378. This way we can find the second number if we are having HCF and LCM and one of the number. One important thing I want to explain here is there are 4 elements A, B, H and L. If any 3 is given, we can find the fourth. If two numbers are given or their product is given and HCF is given, we can find LCM. And if LCM is given, we can find HCF. I hope you have understood this important formula. We will solve 2 more questions based on this formula. We go to the next example. Example 6, second. Two numbers have their HCF 24 and LCM 204. Then we can definitely say about the numbers that option A, only one such pair exists. Option B, only 2 such pair exists. Option C, more than 2 such pair exists. Option D, no such pair exists. Before solving this question, I request you to please subscribe to this channel. We should know that HCF must be a factor of LCM. It means that LCM is completely divisible by HCF. But 24 is not a factor of 204. Therefore, our answer is no such pair exists whose LCM is 204 and HCF is 24. So our answer is option D, no such pair exists, and I am writing the reason. HCF must be a factor of LCM and 24 is not the factor of 204. We go to the next example. Example 6, third. The product of two co-prime numbers is 152 Find their LCM. The given options are option A 208, option B 258, option C 152, option D 119. Before solving this question, I request you to please subscribe to this channel. We know the property of co-prime numbers. If there are two co-prime numbers, then their only factor is 1. Therefore, H.C.F. of two co-prime numbers is equal to 1. And if the numbers are, say, A and B, then their product is given as 152 equal to H.C.F. multiplied by l.c.m. Therefore, l.c.m. equal to 152 upon 1 equal to 152. It is as simple as that. And from the given options, our answer is option C, 152. Here the product of two co-prime number is given to us and we have to find their LCM. LCM must be equal to their product because co-prime numbers do not have any common factor other than 1. So LCM will be the product of that two numbers. And here that number is 152. So our answer is 152. So keep in mind this property. We go to the next point. Point 5. HCF and LCM of fractions. HCF equal to HCF of numerators upon LCM of denominators, and LCM of the fractions is equal to LCM of numerators upon HCF of denominators. The easy trick to memorize these two formula is when we have to find the HCF, then numerator of this formula is HCF of numerator. Here it is HCF, so numerator is HCF of numerator. And when it is LCM, then in the formula the numerator is LCM of numerator. In both the cases, the numerator is numerator and denominator is denominator. When it is HCF, then numerator is HCF of numerator. When it is LCM, then it is LCM of numerator. And in denominator, when HCF, then denominator of it is LCM of denominator. And in LCM, the denominator is HCF of denominator. This way you can memorize it easily. Now we will solve few examples based on these two formula. We go to the next example. Example 7. Find the HCF of 8 upon 9, 16 upon 21, 20 upon 27. Before solving this example, I request you to please subscribe to this channel. We have to find the HCF of these fractional numbers. HCF equal to HCF of numerator upon LCM of denominator. So we have to find the HCF of 8, 16 and 20. This is equal to 4. We have to find the LCM of 9, 21 and 27. All the three numbers are divisible by 3. So 3 times 3 is 9, 3 times 7 is 21 and 3 times 9 is 27. Again 3 and 9 are divisible by 3. So 3 divides 3 for one time. We carry 7 as it is and 3 divides 9 for 3 times. Therefore LCM will be 3 multiplied by 3 multiplied by 3 multiplied by 7. 7 times 3 is 21. 21 times 3 is 63. And 63 times 3 is 189. Now therefore HCF of numerator is how much? 4 and LCM of denominator is 189. Therefore our answer is 4 upon 189. The HCF of 8 upon 9 16 upon 21 and 20 upon 27 is 4 upon 189. I hope you have understood the method of finding H.C.F. of fractional numbers. We go to the next example. Our next example is example 8. Find the LCM of 2 upon 15, 3 upon 10 and 4 upon 25. Before solving this example, I request you to please subscribe to this channel. The formula for LCM of fractional number is LCM equal to LCM of numerator upon H.C.F. of denominator. So we have to find the LCM of 2, 3 and 4, and the LCM is 12 and H.C.F. of 15, 10 and 25 is 5. So our LCM of numerator is 12 upon H.C.F. of denominator is 5. Therefore our answer is 12 upon 5. That is the LCM of 2 upon 15, 3 upon 10 and 4 upon 25 is 12 upon 5. I hope you have understood the formula as well as solving the questions on finding the LCM of fractional number. Before going to the next point, I request you to please subscribe to this channel. We go to the next point. Point 6. H.C.F. and LCM of decimal fractions. Step 1. In given numbers, make the same number of digits after decimal place by adding zeros at the end of numbers. Step 2. Find H.C.F. or LCM of given numbers without decimal. Here it means that you have to leave the decimal and make the numbers without decimal, and then you have to find the H.C.F. and LCM. Step 3. Put the decimal point in H.C.F. or LCM obtained in step 2, leaving the same number of digits in numbers as in step 1. Now I explain all the steps. You have been given some numbers with decimal places. Say in first number, the digit after decimal is 1. Only one digit is after decimal. In second number, the digits after decimals are 2. And in third number, the digits after decimals are 3 digits. Then you have to make all the numbers with 3 digits after the decimal by putting zeros at the end. Now whatever number you have made after putting the decimals, remove the decimal and find the H.C.F. and LCM of those numbers without decimal. Then again put the decimal so that the digits after the decimal is same as in step 1. You will understand it by examples. We go to the examples. Example 9. Find H.C.F. of 2.4, 0.16 and 0.4. Before solving this example, I request you to please subscribe to this channel. The step 1 was to make number of digits after decimal equal in each number. In 2.4, there is one digit after the decimal. In 0.16, there are 2 digits after the decimal. And in 0.4, there is one digit after the decimal. So we have to make the number of digits equal after the decimal. So what we will do? We will make 2 digits after the decimal in each number. So 2.4 will become 2.40. 0.16 has already 2 digits after the decimal, and 0.4 will become 0.40. So now every number has equal number of digits after the decimal. And if we remove the decimal, what the numbers will be? The numbers will be 240, 16 and 40. Now we have to find the HCF of these numbers. And the HCF of these numbers is 8. This is the HCF of 240, 16 and 40 and not the HCF of 2.40, 0.16 and 0.40. So what we have to do? We have to put the decimal in such a way so that the digits after the decimal are 2, as in 2.40 there are 2 digits after the decimal. In 0.16 also it is 2 digits after the decimal, and in 0.40 there are 2 digits after the decimal. So what we do? We put decimal and put 0 and then we write 8. We cannot write 0.80 as 0.80 and 0.8 has the same meaning. So it will be not the 2 digits after the decimal. So what we have to do? We have to put the decimal and then put 0 and then write 8. So this will be our answer for our question. The HCF will be 0.08 of the given numbers 2.4, 0.16 and 0.4. I hope you have understood all the steps of this question. I repeat it again. Step 1 was to make equal number of digits after the decimal. So we made 2.4 as 2.40, 0.16 wrote as it is 0.16 and 0.4 became 0.40. Now we removed the decimal and made the numbers. The numbers became 240, 16 and 40. Now we found the HCF of 240, 16 and 40 and that is 8. Now we have to put the decimal in such a way so that after the decimal there are 2 digits. So what we will do? We will put 0.10 prior to 8. So it will become 0.08. There will be 2 digits after the decimal as asked in step 3. So our HCF of 2.4, 0.16 and 0.4 becomes 0.08. This is our answer. I hope you have understood finding the HCF of decimal fractions. We go to next question in which we will find LCM of decimal fractions. Again we will do the same steps, so it will be more clear to you after seeing the next example. Example 10. Find LCM of 1.8, 0.12 and 3. Before solving this example, I request you to please subscribe to this channel. What was step 1? Step 1 was that we have to make equal number of digits after the decimal. The maximum number of digits after the decimal is in 0.12, 2 digits. So we will make 2 digits after the decimal in each number. So 1.8 becomes 1.80, 0.12 is 0.12 and 3 becomes 3.00. This was our step 1. Now what was our step 2? We have to make all these numbers without decimals. So 1.80 will become 180, 0.12 will become 12 and 3.00 will become 300. Now we have to find the LCM of 180, 12 and 300. So we start finding the LCM. 12 is common in all these numbers. 12 divides 180 for 15 times. 12 divides 12 for 1 time and 300 for 25 times. Now 5 is common in 15 and 25. So 5 divides 15 for 3 times and 25 for 5 times. So our LCM will be 12 multiplied by 5 multiplied by 5 multiplied by 3. This is equal to 900. Here the step 2 is completed. What is step 3? We have to put the decimal so that after the decimal the number of digits becomes same as in step 1. So we have to put the decimal so that the number of digits after the decimal becomes 2. So we will put the decimal here in 900, it will become 9.00. So our LCM is 9. The LCM of 1.8, 0.12 and 3 is 9. This way we can find the LCM of fractional numbers. I hope you have understood the method of finding HCF and LCM of fractional numbers. Now we go to the next point. Point 7. Find the greatest number which when divided by x, y and z leaves remainders a, b and c respectively. This is the type of questions usually come in competitive exams and we have to find the method of solving it. So the method is, in such type of questions, it is observed that x minus a equal to y minus b equal to z or z minus c equal to k. We suppose it is equal to k. Then what will be our solution? Then solution is LCM of x, y and z minus k. And we will learn it by one example. Example number 11. Find the number which when divided by 18, 24 and 32 leaves remainders 7, 13 and 21 respectively. Now you just observe how I solve it. Here x is 18, y is 24 and z is 32 and a is 7, b is 13 and c is 21. The number when divided by 18 leaves remainder 7. So 18 minus 7 is 11. Similarly 24 minus 13 is again 11 is equal to 32 minus 21 is also equal to 11. So all these are equal to 11. This is the value of k. 11 is value of k. Now we have to find the LCM of 18, 24 and 32. We already know how to find the LCM of it. So I am not finding the LCM of it. You find it by yourself. The LCM of this comes out to be 288. So what will be our answer? Our answer will be 288 minus 11, as the value of k is 11. So our answer will be 277. This is our answer of the given question. I hope you have understood the method of solving such type of questions when it comes in competitive exams. Now we go to the next point. The next point is point number 8. To find the least number which when divided by x, y and z leave the same remainder in each case, k is equal to LCM of x, y and z plus k. In many competitive exams, the question asked are of this type, in which it is given that there are three numbers x, y and z and we have to find a least number which when divided by x, y and z leave the same remainder and that remainder is k. And to solve such type of questions, what we have to do? We have to first find the LCM of x, y and z and then whatever the LCM is there, we add k to it and that becomes our answer. And we will learn it by this example. Example 12. Find the least number which when divided by 12, 15 and 20 leave remainder 7 in each case. That least number which we have to find is when divided by 12, 15 or 20. In all these three cases, the remainder is always 7 and we have to find that number. Before solving this example, I request you to please subscribe to this channel. As per the given method, we have to first find the LCM of 12, 15 and 20. And we know the LCM of this. I will not find it out. You already know how to find the LCM of it. So LCM is equal to 60. The LCM of 12, 15 and 20 is 60. And what will be that number? Number will be 60 plus 7 is equal to 67. This is that number. We can check it also. When 12 divides 67, the remainder is 7. 12 times 5 is 60 and 67 minus 67. Similarly, when 67 is divided by 15, 15 times 4 is 60 and the 67 minus 60 is again 7. Similarly, 67 when divided by 20, 20 times 3 is 60 and 67 minus 60 is again 7. So this is our answer. And such type of questions are asked in various competitive exams. And this is the method of solving such type of questions. Now we go to the next point, or the next type of questions, how to solve that type of question. That is point number 9. To find the greatest number that on dividing x, y and z or z leaves the same remainder k in each case when the value of k is given, and this is equal to H.C.F. of x minus k, y minus k and z or z minus k. And we will learn it by one example. Example 13. Find the greatest number which on dividing 748, 976 and 1090 leaves remainder 7 in each case. What we have to do? We have to first subtract 7 from these numbers, 748, 976 and 1090. And whatever the result comes or whatever the number comes, we have to find the LCM of those numbers. 748 minus 7 is 741. 976 minus 7, 969. And 1090 minus 7 is 1083. Now we have to find the H.C.F. of 741, 969 and 1083. And that will be our answer. We will find the H.C.F. of these numbers by division method. We divide 1083 by 741. It divides for one time. 1083 minus 741 is equal to 342. Now 342 divides 741. It divides it for 2 times. 342 multiplied by 2 is 684. 741 minus 684 is 57. Now 57 divides 342. It divides for 6 times. 57 multiplied by 6 gives us 342 and the remainder is 0. Now we find the H.C.F. of 57 and 969. So we divide 969 by 57. 1 time 57 is 57. 96 minus 57 is 39. We carry 9. 57 divides 399 for 7 times and 7 times 57 is 399 and our remainder is 0. So the H.C.F. is 57 and that is the required number. This is the greatest number which divides 748, 976 and 1090, and on dividing always the remainder is 7. I hope you have understood the method of solving such type of questions. Now we go to the next point, in which we will find the type of questions asked in various exams. So point number 10, to find the greatest number that on dividing x, y and z or z leaves the same remainder in each case when the value of remainder is not given, and this will be equal to H.C.F of absolute value of x minus y, y minus z or z, and z minus x or z minus x. Here the three numbers are given, x, y and z or z, and the greatest number which divides these three numbers and leaves the same remainder. But that remainder is not given here. So how to find it? We find the absolute value of x minus y, y minus z or z, and z or z minus x, and we find the H.C.F of these three numbers, and that will be our answer. We will learn it by the example. Before solving this example, I request you to please subscribe to this channel. Example number 14. Find the greatest number which on dividing 1169, 761 and 1305 leaves the same remainder in each case. Here that remainder is not given. Now what we have to do? We will subtract 761 from 1169. This is equal to 408. Now we subtract 761 from 1305. This value is equal to 544. And now we find the difference of other two numbers, 1305 minus 1169, and this is equal to 136. Now we have to find the H.C.F of all these differences, and these are 408, 544 and 136. So we divide 544 by 136. 136 divides 544 for 4 times, and the remainder is 0. So the H.C.F of 544 and 136 is 136. Now we divide the next number 408 by 136, and 136 divides 408 for 3 times. So the H.C.F is 136. So that greatest number is 136. So our answer is 136, which is that greatest number which on dividing 1169, 761 and 1305 leaves the same remainder. If the remainder value is not given, then we adopt this method of solving this question. I hope you have understood the method of solving such type of questions. We go to the next type of questions in next point. Point number 11. To find the greatest number of n digits which when divided by x, y and z leaves remainder k in each case. Now how to solve this type of questions? Step 1. Find LCM of x, y and z. Say it is equal to L. Step 2. Divide n digit greatest number by L, which leaves remainder R. Step 3. Our answer will be equal to n digit greatest number minus R plus k. Now important point is that when k is equal to 0, then x, y and z exactly divides n digit greatest number. In that case our answer will be n digit greatest number minus R. That will be our answer. I explain it again. Suppose the n digit number which we have to find is say a 4 digit greatest number, and that when divided by x, y and z leaves remainder k. So what will be the greatest n-digit greatest number? The n-digit greatest number is 4-digit greatest number, which is 9999. So we will have to, in step 1, we have to find the LCM of x, y and z, and that is suppose L. Then what we will do, we will divide 9999 by L, and then whatever the remainder is there, say it is R, then what we will do, we will subtract R from 9999 and we will add the remainder given to us K to that, and that will be our answer. Now we will learn it by one example. The example given to us is example 15. Find the greatest number of 4 digits which when divided by 15, 18, 20 and 24 leave remainder 11 in each case. What is asked in the question is, you have to find a greatest 4-digit number which when divided by 15, 18, 20 and 24 leaves remainder 11 in each case. Now here the value of k is 11. So we go as explained in the point step by step. So step 1 was to find the LCM of 15, 18, 20 and 24. 15, 18, 20 and 24. Here 3 numbers are divisible by 2, so we divide it by 2. We carry 15 as it is, as it's not divisible by 2. 18 when divided by 2, we get 9. 20 when divided by 2, we get 10. And 24 when divided by 2, we get 12. Still there are 2 numbers divisible by 2. So we divide again by 2. 15 we carry as it is, 9 we carry as it is. 10 when divided by 2 gives us 5. And 12 when divided by 2 gives us 6. Now there are 3 numbers divisible by 3. So we divide it by 3. 15 when divided by 3 gives us 5. 9 when divided by 3 gives us 3. 5 we carry as it is, and 6 when divided by 3 gives us 2. Now we divide it by 5. 5 when divided by 5 leaves 1. We carry 3 as it is. 5 when divided by 5 gives us 1, and we carry 2 as it is. Now our LCM is 2 multiplied by 2 multiplied by 2. 2 multiplied by 2 and multiplied by 2 in the last row, leftover number. Then we multiplied by this 3 and the 3 of the last row. Multiplied by 3, multiplied by 3 and multiplied by 5. This is equal to 2 multiplied by 2 is 4, multiplied by 2 is 8. 8 times 3 is 24, times 3 is 72, and 72 times 5 is 360. And 360 is our LCM. Now step 2. The largest or greatest 4-digit number is 9999. We divide this number by 360. 999 is divided by 360. It gives 2 as quotient, and 2 times 360 is 720. When subtracted from 999, we get 279. We carry 9. 360 divides 2799 for 7 times. 7 multiplied by 0 is 0. 7 times 6 is 42. We write 2 and carry 4. 7 times 3 is 21. Plus 4 is 25. On subtracting, we get 9. 9 minus 2 is 7. 7 minus 5 is 2. 279. Now step 3. This is our final remainder. Step 3 is greatest 4-digit number is 999. minus 279, the remainder, when divided by the LCM, plus the remainder given in the question is 11. So this is equal to 9731. This is that greatest 4-digit number 9731, which when divided by 15, 18, 20 and 24 leaves remainder 11 in each case. I hope you have understood all the steps of solving such type of questions. We go to the next question. Our next example is example 16. Find the greatest number of 4 digits which is exactly divisible by 15, 18, 21 and 24. Before solving this example, I request you to please subscribe to this channel. What is our step 1? We have to find the LCM of 15, 18, 21 and 24. We first divide it by 2. 15 we carry as it is. 18 divided by 2 gives us 9. 21 we carry as it is. 24 divided by 2 gives us 12. Now there is no 2 common number divisible by 2. So we divide it by 3 as all the numbers are divisible by 3. 3 divides 15 for 5 times. 9 for 3 times, 21 for 7 times and 12 for 4 times. Now we don't find any 2 numbers divisible by any number. So our LCM will be 2 multiplied by 3 multiplied by 3 multiplied by 4 multiplied by 5 multiplied by 7. 2 times 3 is 6. 6 times 3 is 18. 18 times 4 is 72. 72 times 5 is 360 and 360 times 7 multiplied by 0 is 0. 7 times 6 is 42. We write 2 carry 4. 7 times 3 is 21 plus 4 is 25. So 360 multiplied by 7 is 2520. This is our LCM. Now the greatest number of 4 digit is 9999. We divide this by 2520. It divides for 3 times. 3 times 2520 is 7560. On subtracting we get 9 minus 0 is 9. 9 minus 6 is 3. 9 minus 5 is 4 and 9 minus 7 is 2. Now step 3 is 9999 minus the remainder 2439. This is equal to 7560. This is our answer. It means that 7560, that is 7560, is the greatest 4-digit number which is exactly divisible by 15, 18, 21 and 24. I hope you have understood the method of solving such type of questions. Next type of questions which are asked in various competitive exams is of the form given in point 12. To find the smallest number of n digits which when divided by x, y and z leaves remainder k in each case. Now how to solve such type of questions? The steps are given here. First let me explain you the question. We have to find an n digit smallest number which is to be divided by x, y and z and that leaves remainder k in each case. We have to find that number. What we have to do? Step 1. First we have to find the LCM of x, y and z. Suppose it is equal to L. Then step 2. So step 2 says that divide n digit smallest number by L which leaves remainder R. If we divide n digit smallest number by L and then we get the remainder R. Then what we have to do? In step 3, our answer will be n digit smallest number plus L minus R plus K. Here 1 digit smallest number is 1, 2 digit smallest number is 10, 3 digit smallest number is 100, 4 digit smallest number is 1000. So this way we have to find the n digit smallest number. Then we have to divide that number by L, which is the LCM of X, Y and Z. And on dividing we get the remainder R. Now in that n digit smallest number we have to add the difference of L minus R, and again we have to add the remainder given to us in question, which is K, and that gives our answer. Important note is that when K equal to 0, it means that in the question the remainder is 0, or X, Y and Z exactly divides the n digit smallest number, and we have to find that number. Then what we will do? We will leave this part, plus K part. Our answer will be n digit smallest number plus L minus R. I hope you have understood the point. I will further explain you by example. We learn the point by the example, which is example 17. Find the smallest number of 4 digits which is exactly divisible by 8, 10, 12 and 15. Step 1 is to find the LCM of 8, 10, 12 and 15. We divide it by 2. 2 divides 8 for 4 times, 10 for 5 times, 12 for 6 times, and we carry 15 as it is. Further 2 numbers are there which are divisible by 2. 2 divides 4 for 2 times, we carry 5 as it is. 2 divides 6 for 3 times, and we carry 15 as it is. Now we divide it by 3, we carry 2 as it is, 5 as it is, 3 times 1 is 3, and 3 times 5 is 15. Now we divide it by 5, we carry 2 as it is, 5 times 1 is 5, we carry 1 as it is, and 5 times 1 is 5. Now our LCM is 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. 2 times 2 is 4 times 2 is 8 times 3 is 24 times 5 is 120. So the LCM is 120. Now the smallest 4 digit number is 1000. We have to divide 1000 by 120. It divides for 8 times. 120 times 8 is 960. 0 minus 0 is 0. 0 minus 6 is 4. And 9 minus 9 is 0. So remainder is 40. Now our answer is 1000 plus our LCM minus this remainder. This is equal to 120 minus 40 is 80, and 1000 plus 80 is 1080. This is our number. The smallest 4 digit number divisible by 8, 10, 12 and 15 is 1080. I hope you have understood the method of solving such type of questions. We solve one more example in which the remainder is given. Our next example is example 18. Find the smallest number of 4 digits which when divided by 9, 12, 21 and 28 leaves remainder 7 in each case. Before solving this example, I request you to please subscribe to this channel. Our first step is to find the LCM of 9, 12, 21 and 28. So we write 9, 12, 21 and 28. We divide it by 2. We carry 9 as it is. 2 times 12 is 6. We carry 21 as it is not divisible by 2. And 28 when divided by 2, we get 14. Still 2 numbers are divisible by 2. We carry 9 as it is. 2 times 3 is 6. We carry 21 as it is. And 2 times 7 is 14. Now we divide by 3. 3 times 3 is 9. 3 times 1 is 3. 3 times 7 is 21, and we carry 7 as it is. Now we divide it by 7. Carry 3 as it is, 1 as it is. 7 times 1 is 7 and 7 times 1 is 7. So our LCM is 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 7. 7 times 3 is 21 times 3 is 63. 63 times 2 is 126, and 126 times 2 is 252. Now we go to the step 2. Step 2 is the smallest 4-digit number is 1000. We divide 1000 by 252, which is the LCM which we just found. It divides it for 3 times. 252 times 3 is 756. We get the remainder 244. Now our answer will be 1000 plus LCM is 252 minus this remainder 244 plus the remainder given to us in question is 7. This is equal to 1000 plus 8. 252 minus 244 is 8 plus 7. This is equal to 8 plus 7 is 15 plus 1000 is 1015. And this is our answer. It means that the 4-digit smallest number, which when divided by 9, 12, 21 and 28 leaves remainder 7, is 1015. I hope you have understood the method of solving such type of questions. Here completes the basics of LCM and H.C.F. We will be solving many questions of LCM and H.C.F. similar to the questions asked in various competitive exams. One important point I want to say about H.C.F. When we have to find the H.C.F. of given numbers, then H.C.F. is never greater than the difference between any of the given two numbers. I will explain it by example. 12 and 21. The difference between them is 9. Our H.C.F. can never be greater than this 9. It can be equal to 9 or less than this 9. Here the H.C.F. is 3. The H.C.F. of 12 and 21 is 3, and it is not greater than 9. So H.C.F. can never be greater than the difference between the any of the two numbers. If we add one more number, 12, 21 and 27. Here the difference between 12 and 21 is 9 and 21 and 27 is 6. Our HCF can never be greater than 6. Here also the LCM will be 3. The LCM is 3, which is smaller than 6. I hope you have understood this property. In one of the questions, say we have to find the HCF of 408, 544 and 136. If we subtract 408 from 544 minus 408, then we get 136. And another number is already 136. It means that our HCF is 136. This way we can find the HCF even without going to many calculations. And HCF can never be greater than the difference between the any two numbers of the given numbers. I hope you have understood this property of HCF. Here completes this topic of HCF and LCM. Please do lot of practice from various books of all the topics of quantitative aptitude to become expert in solving the questions of quantitative aptitude. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.